Chapter 1, Part 2. We're going to go back to the idea of hypothesis. We have a null hypothesis and we have alternative. The null is equal to its status quo, meaning no change. The alternative is going to be the change. It's the researcher's claim, not the popular belief. So this is the popular belief, where this is the researcher's claim. The researcher is claiming that it's different than the population or the popular belief. So to be different than the popular belief means not equal to, less than, or greater than. And we'll be looking at those here as we go. The level of significance is alpha, and it's the chance of a type 1 error. Because the level of significance is that level in which I'm going to reject. So if I'm looking on a continuum, and this is alpha, my level of significance, if I am on this side, I am going to accept the null, and if I'm on this side, I'm going to reject. So this is my cutoff, my level in which I am going to reject. Because I'm rejecting, I could possibly have made a type 1 error. So when I read in the study or anywhere it says statistically significant, what it said is I've rejected the null. In other words, I have landed in this space. Now notice, this isn't a normal distribution. It's just a continuum, like a number line. So the p-value then is this probability that I land in relation to alpha. P for probability. So the p-value can be located in a couple places. The p-value might mean I landed on this tail. And if so, this is on the right. The p-value might be that I landed on the left, which would be in this lower tail, or the p-value might be that I landed on either side because I wasn't sure what side to land on, so maybe I had a choice of landing in one of these two tails. So the p-value is the probability that I get an observation. So it's the probability of my evidence, assuming the null is true. So I made that assumption that what we believe, the popular belief, is true. I go out and get evidence. The evidence is based on this popular belief. How likely is it that I would get this evidence or any more extreme if this null is true? And so what we need to do then is we compare to the alpha level to see, is it unlikely enough that I'm going to reject? Or maybe it's not unlikely enough, so I'm going to keep it. Now, when we reject a null, we're making change. We don't want to make change. It's a popular belief. It's already kind of been looked at. We want to believe that it's true. We're going to get this evidence, and then we're going to make a decision based on the evidence. It's just like the court system. We believe they're innocent. And then we go out and get evidence and see if it is strong enough to prove that they are not innocent. So the type 1 error, remember it when that happens, is when I reject the null but make a mistake. The chance of a type 1 error is my alpha level. So we want this chance to be small. Because we don't want to make errors. And a type 1 error is when I reject. I've already kind of thinking the null is true, so I'm not going to reject unless I'm darn sure. So that's where it comes in, that the p-value versus significance level. If you go back and look at this continuum here, the p-value versus significant just says alpha is my cutoff. So if I happen to get a p-value that falls on this side of alpha that's bigger, it's not unlikely enough, so I accept. If I get a p-value on this side, notice these on a continuum are smaller values, and these are larger values. So if I land here, I'm in the reject region. So it's the p-value and its comparison to alpha, the significance level. So if I have a small p-value, that means the probability, p for probability, of me getting this observation is small or unlikely. Is it unlikely enough? I don't know. The p-value gets compared to alpha, and then I make my decision. If it's smaller or equal to, I reject. So at this region right here, on this side I reject if my p-value is unlikely enough as compared to alpha. So let's look at some problems. P-value large or small to reject, the p-value must be small to reject. If the study was significant at the 10%, what would be a possible p-value? So what it's saying is here's 10%. This is always my accept if I'm larger, my reject. Now this does not have to do with direction of tests. If this value is 10%, that's my alpha, anything on this side would cause me to reject, which is another way of saying statistically significant. So 9% would make me reject, 8%, 10% would make me reject, and so forth. Anything less than 10% or 10% itself. If a study was not statistically significant at 1%, what would be a possible p-value? So again, looking at my number line, here's 1%. If I'm larger than that, I accept. So if I'm not statistically, that means I am accepting the null. So I'm on this side of 1%. So anything greater than 1%, such as 2%, 3%. There's infinitely many numbers. If a study is statistically significant at 5, it is statistically significant at 1 and at 10. Well, let's take a look. So here's my 5%. Again, on this side, if my p-value is on this side, I accept. If it's on this side, I reject. Numbers on this side are 4, 3. Numbers on this side are larger numbers. So when I look at here, this is my reject accept. If I'm smaller than 5, it's saying, is it statistically at 1? Is it statistically significant at 1%? Well, 3 is statistically significant at 5, but not at 1. So no, you're not guaranteed. I could have landed down here, but just to be significant at 5, that means I could have had a percent of 4. Does it mean I'm significant at the 10%? Well, 10%'s up here. So if I'm significant at 10, this whole side would be my reject, so I would also be significant at the 5. So if it's significant at the 10, okay, 5% is below 10, so yes, I would be. That's kind of a trick question. There's one similar to that in picking p-values, but not quite that much analysis needs to take place. The null always contains the equal sign. Remember, our book uses equal, but you could also use these depending on the test. The researcher's claim is always that alternative hypothesis. And the rejection region comes from that alternative hypothesis. So if I am greater than, mine is on here on the left. If I'm less than, my rejection region is on the right. And if I'm not equal to, my rejection region, both sides. So when I look these up in the book in chapter 10, if I find this p-value, what I need to make sure in this test, this is also the p-value, and because it's symmetric, these are the same size, so I need to take 2 times the p-value. But in your textbook, that's what you do if you're using the calculator. Your p-value is automatically doubled on that calculator if you happen to have one.